welcome. So in today last week I did a video on staircase design, the architectural design of a staircase, how to know the number of a riser and the number of a tread. So in today's video I'm going to be doing more examples on about 2 examples on the design of staircase. So I felt the example I did the other day was not enough because as site engineer or as an architect, people don't expect you to, even if you know the theoretical knowledge is not what people need. What they actually need is the practical knowledge of how you are able to solve this problem. That is why we are engineers and architects. So in this video, I'm going to be doing 2 more examples on the design of a staircase. So at the end of this video, if you find this video interesting, you can give me a like. Now, what does that do? The like tells me that I have someone that is interested in the video and probably will want to do more. And if you have any question you want to ask, you can comment in the comment section and I will respond. So let's dive into today's video. So we are going to start with I said this is the part 2. So I will take the first one as the part 1 where I did some theoretical work and a design. Here I'm going to be doing 2 designs. So and the content is more design. So I'm going to be using this drawing. I got this from an architectural drawing, and this is our workspace. Then the other drawing, and this is our workspace. So those are the things we are going to be doing today. And at the end of this video, I hope you know how to design a staircase, how to get a sufficient riser and thread for your design. So let's start. This is the design of staircase. This is the part 2. And okay, so we can just start with this drawing to save time. You can just start with this drawing. Let me zoom in so you can see what we'll be needing. So we are going to need the total rise from the elevation, but although this is a section, but we are still going to get it there. And this length of this length provided for the staircase, this is the first landing and this is the other landing then to the first floor. So you are going to come in and go from here. So let's look at what we need, the parameters we need, and we can continue from there. Remember the formulas I gave you in the last video, so we are still using the same formula, but we are going to start from here now. So total rise from the drawing. Total rise. What's the total rise of the building you want to design? So let me come here and let me build it so we can see it better. So total rise, I get my total rise from here, and looking at this, it is 2-1 plus I think this is 1250 plus 150. That is from the top of the of this ground floor slab to the top of the first floor slab. That is what will give us our total rise. So it is 2-1 plus 1250 plus 150. So where's my calculator? So I can say 2-1 plus 1250 plus 150. Now my total rise is 35. Now I come here, I input my 35 mm. Then total run. What's my total run? And I said total run is length provided minus landing depending on the numbers of landing you have. So let me zoom this again. Okay, I think you can see from here. You can see it from here. Okay, let me assume this. We have 4815, and the architect is telling us that the landing here is 1665 and the other landing is 900. That's we are going to do 4 to get our total run. What we are going to do is 48155 minus these 2 landings, right? So here's my calculator. It's 4815. So we are going to do 4815 minus 900, then minus 165 if I'm not wrong. Nice. 3915. Okay, 165, I'm right. 3915. So that one is 3915. Now let me confirm if I'm right. Okay. No, I think I'm getting it wrong. Let me take it again. 4815 minus 900 4815 minus 900. Yeah. 4815 minus 900, okay, minus 1665. So I'm going to have 2250. 2250. 2250. So the 2250 is for one flight. So this flight is 2250. The other flight is 2250. So remember I said the first thing we are going to do is to get the number of our risers. So how do we do that? It is the total rise from this formula. Total rise divided by assumed height of riser. So we can say 35 divided by assumed height of riser. Let's take our riser to be 150. So let's say 150. We want to start with 150. Now 35 divided by 150. What do I have? 35 divided by 150. So I'm going to have 23. Let's omit this because it's just small, so we can just add it to one riser or just distribute it within 2 or 4 risers you get. So let's say 23. So my riser is 23 numbers. So my risers is 20. The total riser I need is 23 numbers. So and I have 2 flights in this staircase from this. You can see that I have the first flight. This is the landing. I have the second flight. Since I'm having 2 flights, so let's say I want the first flight to be out of 23. I want it to be half of 20 is 11.5. So I can say I want the first one to be 11 and the next one, the second flight, to be 12. So 11 risers, and I'm going to have 12 risers, making 23, right? Yes. Now the thread. So I know that my thread is for the first flight is 2250. Okay, let me take it like this: a number of thread. I always told you that if you have 2 landings, then your thread will reduce by 1. So if your riser is 5 and you have 2 landings, your thread is 4. If your riser is 10 and you have 3 landings, then your thread is 8. So we're having 2 landings for the first flight. This for the first flight, and this for the second flight. So for this first flight, you have a landing here and you have a landing here. There is 2 landings, so our thread will reduce by 1 of these times. Our thread is going to be 10 for the first flight. For the second flight, because we are still having a landing here, this landing, and we have another landing here, so that one is going to be 11. So 11. I know that number of riser will be 11. Number of riser will be 10 here. 10 here. So what I now need to get is the number of thread. Number of thread that I need. Now I can just take this. It's just simple. I can just take that. I know I have 2250 from the first flight. So I can just say 2250 divided by what will give me 10. Is that not so? 2250 divided by what will give me? So it is divided by 225. So 2250 divided by 225 is going to give me 10. We don't need a calculator for that, right? So it's going to give me 10. But I don't even need to go to the second flight. Looking at this, I've seen that this is 225. And remember what I told you, that if we have 225, 225 is below 250. The minimum thread you can have is 250 mm. Our riser is right. We have the minimum riser. Riser said you can have is 150 mm, and the minimum thread is 250. But now we're having less than 250, so that does not work. Does not work. So it means we come here and increase our riser, or so you can increase our riser and then have more thread. Or if I'm looking at this now, this is too long. This landing, I don't know why the architect provide 1665 as landing. But one of the things we do in this profession is you don't alter what the architect is doing. As a site engineer or an engineer or anybody, if you see a mistake in the architecture or another profession, if you see a mistake in their drawing, you are not meant to correct the drawing. Get back to the designer, and the designer will know what to do, share knowledge, and you understand, you're going to have better solution. But if I was to be the one in charge of this, I'm going to reduce this landing. Probably I can give it 1-1. And yes, 1665 is too large for me. But irrespective of that, I'm not going to reduce the landing, so we'll still leave it at that. So what I just need to do is to increase my riser, then the number of thread will also increase by this value. So what we are going to be, let me just bold this. I'm doing this for a purpose. Okay, this and this, because those are the major parameters we need to get our answer, to get what we are going to. So I said your riser should be a maximum of 160, 180 rather, the minimum of 150. So let's do 165 now. That's 35 divided by 165. We are starting from, it's as if we have done the first part. Our answer was wrong. No, we got 150 for the riser and 225 for the thread, which is not sufficient. So we need to redo the design again. That's why we are using 165 now. Now, 35 divided by 165. 35 divided by 165. What do I have? I have 21.1. So let's say 21. The 0.2 can be distributed between 2 or 3 risers. I have 21 this time. 21. So I have 21 risers. So since I have 21 risers in total, I can say on the first flight, I want 10. And on the second flight, I want 11. Your own can be different, but I love doing it this way. That is what is common around there. Understand? So I can say this one is 10, and I can put this one to be 11. So since I need 10, and I know that my thread will reduce by 1 because I'm having to land it, so I'll change this to 9. And I'm going to change this to 10. 10. Now, 225 divided by 9 will give me what? 225. No, this divided by this will give me this. So you can also say this divided by this will give me what is here. Where's the calculator? 2250 divided by 9. It's going to give me what? Okay, that is going to give me 250. Yeah, very good. 250. So meaning I can just copy everything as well. Copy. Can paste this there. Equals to. However, this is going to, no, this is 10. So here I'm going to have plus 1. Is that not 2? Okay, 2. Yes, because I'm having 11. So it's going to increase by 1. So meaning that when you get to this last riser, say, coming. Meaning that when you get to this last riser, you are going to add another 1. That's what we are doing here. So this one is 2250, but this one we are going to have 25 as the total run. So meaning we are going to have add 1 here, but the architect didn't add it. But from the design we just did now, you saw that even the architect even did 250. Are you saying it? The thread, he did 250, but he didn't tell us the riser. But from this now we've gotten the number of riser. So to go ahead with this drawing, you have 165. 165 is still between the range of 150 to 180, which is sufficient. So 250, the minimum thread we can have is 250, and now we are having 250. That is okay. So that is okay. So we can then decide that okay, after our calculation we have 165 mm, which you are going to use for your riser, and 250 mm, which you are going to use for your thread. I'm convenient with this. If this is not convenient for you, you can go ahead, increase the riser to about 180 or 175. That is going to increase the number of your thread, understand, to about 260, 270, if not up to that. Then, and another thing you can do is just to reduce this landing, because I feel it's too much. But and if you don't want to do that, this is okay. This is okay. So we are done with this design. No, the first one we got the riser to be 150 and the tread to be 225, which is not okay. But this now is between the range of, this is between the normal range, and this is the minimum for tread. So we are okay with this. Okay, so I don't need to draw the plan in AutoCAD just like I did the other time. This one is very easy to understand. So we are done with this design. Now let's go to the other one. So the next one is this. We are having a dining in between the stair, and the stair is, it has 3 flights, just like the one we've been doing before, which is 2 flights. And we have the first flight, we have the second flight, and we have the third flight. Here we are having 4 landings. This is a landing, this is a landing, this is a landing, and this is a landing, and there is a dining here, and probably under here will be maybe a store. I don't know, anything, it can be anything. The second design, we have 3 flights. We have the first flight, the second flight, and the third flight. So I'm going to be doing this with a little different approach. The approach is going to be different. Here I'm going to remove the landing, so we can just do our calculation once, and just, I will not divide it into flight this time around. So let's start. What do we need first? We need total rise. So from this one, I didn't get the height, so I want to use 3150. So 3150. Let me use 3150. So the total run is the length of, I mean, the length where you have the tread and the riser, excluding the landing. No, the formula is length provided minus any landing you might have. So we are going to do this. So looking at from the wall, okay, from the wall here to the first riser is 1950. So what we are going to do is 1950 minus 12. Then here from this wall to this wall here is 4150. We are going to minus 24. That is this landing and this landing. Then this 2475 from here to here, we're going to remove 12, and from there we are going to have the total run we need. So 1950 minus 12. Let's start with that. 1950 minus 12. So I'm going to have 750. So I can put that here. 750 plus. So then the next one is 4150 minus 24. I hope you understand we got to 4. So 4150 minus 24. So I'm having 1750. I can put that here again. 1750 again. Okay. 1750. Then the last one is 2475 minus 12, the landing. 2475 minus the landing. 2475 minus, which is 12. So I'm having 1275. 1275. So I can add 1275 plus 175 plus 750. 1750 plus 1750 plus 750. 750. So I'm going to have 3775. 3775. 3775. So that's the length of my run. So let me come here. And since I have 3150, so just like from the former one, I would say, let me assume 150 first. So 3150 divided by 150. 3150 divided 150. I'm going to have 21. Since I'm having 21, I said I don't want to do this by the way I'm doing it, 2 flights. So let me do it with 1 flight. So since I know it is 21, and I have four landings. 1, 2, 3, 4. So it means my thread will be minus riser minus 3. That's 21 minus 3. I'm going to have, is that not 18, 19, 20, 20, 18. I'm going to have 18 as my, what is it again? 18 as my riser. My riser will be 18. So then I cannot divide 3775 divided by what will give me 18. So 3775 divided by what will give me 18. So I can use my calculator. So I can say it is 3775 divided by 18. So I'm going to have 209.7. Let's say 210. Let's say 210. Let's say this is 210, which is not sufficient. You get the logic? It is not sufficient. I cannot have a riser or a thread of 210. It's too small. It's too small. So this is not sufficient. So what do we need to do? Let me check. Just like usual, you can say let's increase this, but we are not doing that. We are not altering the drawing. We are just walking around the drawing to get what we want. So I'm going to increase it to 165, just like I did for the former. 165. That's 3150 divided by 165. So what do I have? I have 19. Exactly 19. 19. So if I have 19, my thread is going to reduce by 3, which is going to give me, isn't that 16, 17, 18, 19, 16? Yes. That's going to give me 16. So 3775 divided by 16 will give me what? 3775 divided by 16. Yeah, that is 2350. 2350. No, 235 rather. Let's say 236. 236, which is still not sufficient. Your thread cannot be less than 250. You see the challenge we are having here now. This does not work. So what do we still need to do? Increase the riser again. We don't want to alter the drawing. I didn't want to alter the drawing, we would have gotten our answer. They just increase this. Okay, we cannot increase it because there is a door here. Right? Okay, this is the ground floor. We don't know what is on the first floor, but this is very sure we can extend it. But we don't want to touch that. We are not doing that. So 3150 divided by 170. So we are doing it for the third time now. 3150 divided by 170. So I'll be having 18.5. No, I don't like that. Let's say 3150 divided by 180. Okay, let's say 175 divided by 175. So I'll be having 18, exactly 18. So I think I like this now. 18 now. So this will also reduce by to 15 because you have 4 landings. It's going to reduce to 15. So 3775 divided by 15. 3775 divided by 15. Now I'm going to have 251.6. 251. Okay, 0.7. 251.7. 251.7. So this is okay. The minimum for the riser and the maximum is between 150 to 180. We have 170. It's okay. The minimum thread you can have is 250. We are having 251.7. That is okay. And that is what we've been looking for. That took us 3 tires to get. Sometimes it might be like that. You understand? So that's it. 251.7. So probably because I did the design, I draw this out in AutoCAD in the last one. That's why I didn't draw it. So let me draw this let's see how it will look like if we are actually right or we are wrong. I'm going to draw it and it's going to look like this. So we are first going to produce our triangle, which is 4150 by 48. Now let's use our AutoCAD. 4150 by 48. So let me use my line 4150, comma 48. So this is what you are looking for. So I can form my wall. I can form my wall. So I offset to 30. I'm going to have my wall. So let me check 48. No, I think I'm going to rotate it. The 48 is on this side. So I need to rotate this. So I rotate it this way. 48. Let me measure it and be sure of what I'm doing. 48 exactly. So our 48 is facing this side. And we already know that our landing is 1 2 1 2 1 2. So I just explode and offset. Explode this. So I can begin to offset 1 2 now. I can offset 1 2 inward. I offset another 1 2 inward. I offset another 1 2. So from this offset now I can begin to pick my riser and my thread. So if I look at it, the riser is 170, but I don't need that, will not show in the AutoCAD because the plan is a plan. You are looking at it from the top, right? So what I'm going to get is a thread. So for the thread, I'm going to offset 251.7. So let me offset, and from the drawing we have 3 here. So anything this one gives me, and I continue from here. So 251, and I'm going to have a total of 15, 251.7. I'm going to have a total of 15. So let me go back there. Offset 251.7. Enter. So here I can take this 1, this is 2, this is 3, right? This is 4, this is 5, 6, 7, 8, 9. So this one is going to flush with this, but there's a little space, so that doesn't matter. 10. So we have 11, 12, 13, 13. So I'm continuing for 14 and 15. So that's then I can trim those one I need to trim to have a better look. I trim this out. I don't need this. 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 So we are done. This is it. So this is what we have. If you look at it, we have three thread there. So we are having 3 here. 1 2 3. And here we have 1 2 3 4 5 6 7. 7. So here we have 1 2 3 4 5 6 7. Here we have 1 2 3 4 5. So I think I went to that. So 1 2 3 4 5, and that's all. So that's all. So we've been able to do 2 examples now. So this one gave us a riser of 170, and the other one gave us a thread of 251.7. Then this one gave us 165 and 25, and that's how to do the design of a stair, the architectural design of a staircase, to know the number of your riser and your thread. And with this, we've come to the end of the video for this design of staircase. So you can, just like I said in the beginning of the video, you can give me a like if you find this interesting. And what that does is to tell me I've really done well and I need to do more of it, just like a form of encouragement to what I do.